14 billion years ago, all the stars in the night sky, all the galaxies our largest telescopes can see, all the energy, radiation, planets, and the matter that makes up our bodies was contained within a tiny region smaller than the size of an electron. This unimaginably dense and hot region roiled under the constant fluctuations allowed by our theory of the smallest distances, quantum mechanics, and rapidly expanded under the influence of general relativity, our theory of gravity, and Einstein's greatest achievement. Nuclear reactions like those in the center of the sun took place throughout the expanding space, fusing protons together to make helium and lithium, and ceasing as rapidly as they began as the growing space cooled. Light, the most ubiquitous energy in the early universe, also cooled, losing energy until it was so feeble it could not prevent the protons and electrons coming together and forming the first atoms in the cosmos. This cold leftover glow of the initial cosmic fireball was then condemned to travel uninterrupted through the expanding universe, an aging snapshot of the earliest times. Meanwhile, the quantum uncertainties of the early universe had been stretched by the expansion to become the initial lumpiness of matter, which grew under gravity's constant attractive power to form the galaxies and stars we see overhead. These first stars took the elements forged in the heat of the Big Bang and merged them at crushing pressures and searing temperatures into the heavier elements, including carbon, nitrogen, and oxygen. And over millions of years, these stars used up their nuclear fuel and, exploding as spectacular supernovae, spewed their products into the late universe, where they were free once again to fall under gravity's attractive spell and form later generations of stars and the planets that orbit them. 14 billion years later, those remnants of stellar death are arranged into the most complex and wonderful forms. They built telescopes, laboratories, and giant colliding machines to measure the leftover glow of the Big Bang and to probe the quantum world from which it arose. They gaze at the night sky and the interiors of atoms and marvel at how phenomena from both have conspired to make the universe the way it is, and at their good fortune to be able to comprehend even a small part of this grand cosmic story. Thank you.